kind of trig are we going to do tonight?
So today we just started on graphing the trig identities.
Graphing the sinusoidal equation?
We did sine, cosine, cosecant, and secant.
Oh, okay. So you did graphing of the individual 6 trig functions.
Yeah.
Okay. But you know how to graph those by heart? Let's do the most important one, sine.
Okay.
Tell me the 5 key points on the x-axis and the 2 key points on the y-axis.
5 on the x are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi.
And you realize why those are key points?
Yeah.
Because this is where it reaches its high, this is where it reaches its low, and these 3 places are where it crosses the x-axis.
Yeah.
So on each trig function, you basically want to be able to do this. Now, the reciprocal of sine is cosecant. And what that tells you is that whenever the sine is equal to 1 or minus 1, that the cosecant has to be equal to that also, because the reciprocal of 1 is 1. Yeah. So the way I remember the cosecant curves is they sit on the tops and the bottoms of the sine curve. And they have vertical asymptotes that they approach, because whenever the sine is equal to 0, the cosecant is undefined. It's infinity. Notice that these go to infinity. And then the cosine is kind of the same thing. If you draw the cosine curve, the secant sits on tops and bottoms of the cosine curve.
Yeah.
Tangent's a little different. It also has asymptotes. It goes from there like that. And notice how cotangent is different than tangent. There's a very specific difference about it that you might not notice. This is tangent. Well, cotangent has its asymptotes these asymptotes are minus pi over 2 and pi over 2. But cotangent goes from 0 to pi, and it's the reverse. It looks a lot like the negative tangent. Only difference is it's between 0 and pi. Whereas if I graphed the negative tangent, it would look like this. Same exact shape as cotangent, but different vertical asymptotes.
Yeah.
Pi over 2 shifted, basically. So there's your 6 trig functions.
All right.
Okay. Now, at some point, you may have started, you may not, but you're going to start investigating what happens when you put numbers in front of that.
Yeah, we started that today.
Okay, that's called the sinusoidal equation. And its general format is this. Tell me if your general format is different than this or uses different letters.
We didn't do anything like that today.
You haven't gotten quite this far yet? Okay.
Well, we kind of just, he gave us examples, I don't know, negative 10 cosine of pi x over 6, and we just graphed it from that.
Okay, well, that actually ties into this equation here. In other words, if I gave you the equation y equal 2 sine of x, A is 2, B is 1, C is 0, and D is 0.
Mm-hmm.
And you plot this, it's just a vertical stretch. Instead of the sine curve like that, it's twice as high, twice as low. Looks like that.
Mm-hmm.
So this A acts as a vertical stretch. In the same way that if I said y equals 2x squared, the 2 would act as a vertical stretch of the parabola y equal x squared.
Right.
And what you're going to do is figure out the meaning of each of these letters. In other words, what would it mean if I said, what is this? Sine of 2x. Well, here A is 1, but B is 2.
Yeah.
And what's important to know, I may be giving you some stuff that you haven't learned yet, but you'll learn it tomorrow probably or the next day.
Mm-hmm.
In order to figure out how to graph that, I have to know that the period of my function is always equal to 2 pi over the letter b. So in this case, b is 2, so my period is only going to be pi. So instead of a sine curve going from 0 to 2 pi, it's going to get its entire cycle n by pi. So this would be y equals sine of 2x.
Mm-hmm.
And notice that when b is a number greater than 1, it has the effect of a horizontal shrink.
Mm-hmm.
In other words, this curve would have looked like this, and I've basically smushed it together by a factor of 2. If this b is a number between 0 and 1, you're stretching it apart.
Mm-hmm.
So this b kind of has an opposite effect of the a. The a acts as a vertical stretch or shrink. The b acts as a horizontal stretch or shrink. And a is a stretch when it's greater than 1. B is a shrink when it's greater than 1.
Okay.
Okay? So the one you just gave me, you said y equals minus 10 cosine of pi over 6?
Yeah.
Okay.
It's pi x over 6.
Pi over 6x, excuse me. Okay, so if we go to graph that, what's A and what's B?
A is going to be negative 10.
B is,
Pi over 6.
so the period is what?
The period is going to be 12.
What's the consequence of this negative sign?
Won't that just flip it over?
Over the x-axis.
Yeah.
So if I make that 10, this minus 10, cosine, the normal cosine curve, which would look something like this, going from 1 to 1, it's now going to go reflect over the x-axis. It's going to have an amplitude of 10, so let's just graph it one piece at a time, which I find to be worthwhile. So just y equals minus cosine of x flipped over the x-axis, okay? You with me? So that would be just y equals minus cosine of x. This is going to be y equals minus 10 cosine of x. And since my period is 12, that has to be 12 right there.
Okay.
Because to find the period, you go from a starting point to the next cycle of that same starting point. And a lot of ways to find the period. If you have something that looks like this, you can just take the distance between any two peaks, that's the period, or any two valleys, or any spot where there's one and there's another where it starts up again. So finding the period is just finding two peaks or 2 points on the curve that are kind of at the same spot for the next part.
Okay.
So this is how I would plot it, but I would do it using this. In other words, I would do it exactly the way I went through. I would spell out what A is, what B is, what the period is. If there is a phase shift, then we would say what C is and figure out what the phase shift is. Have you dealt with phase shift yet? The C?
I don't.
Sounds
Yeah,
like maybe you haven't. If this is as complicated as you've gotten, there's no C in that, and there's no D. D is relatively easy. If there is a D, just moves everything up by that amount. In other words, this was y equal -10 cosine of pi over 6x. If I put a +2 on that, then this whole curve just shifts up 2 units. So it now goes from 12 to -8.
Okay.
And if there is a C, if it's something like this, let's put a number in there. Like this down here, the difference between the curve, this one here, and this is this one has a phase shift of what?
2.
Which way?
To the right.
To the right. Which means I would take this curve. Actually, the way I deal with phase shift is I find where the starting point would be, find out where the ending point would be, divide that up into fourths. So if I had a phase shift, I would go to 2, start there, realize my period is 14, which means I got to go to 14. Then I would break up the interval from 2 to 14 into fourths, and then draw my curve like that. So it basically would start here, and it would look something like that.
All right. So can we just do like a few practice ones?
Yeah, for sure. Go ahead. You give them.
Just go with y equals 3 cosine of x plus pi.
What are A, B, C, and D?
A is going to be 3, B is still 1, C is pi, and D is 0.
C is minus pi,
Okay.
and D is 0. Okay, so let me graph the normal. So that's just y equal cosine x. So what's my first step into plotting this one up here?
Let's say changing your y-axis so it's just 3 and -3.
Okay. So I know I'm going to go up to 3 and down to -3. Now what?
Then that pi is going to shift it to the left by pi.
Okay, let's see. This must be minus pi over here. Now what?
So it's pretty much the vertex is going to be right.
The best thing to do at this point, figure out what your period is, mark off your beginning and ending points, divide it into fourths. So this is going to be my beginning point. Where's my ending point?
It's going to be at pi.
Divide that into fourths. There's one. There's another one. There's another one. That's minus pi over 2. That's plus pi over 2. And that's 0. So now I know exactly where to start and where to end.
Yeah.
First point would be right there. And my last point right there. And I know I've got to hit, I'm going to go through the x-axis right there. I'm going to go down and hit minus 3 at that point. I'm going to come back up through the x-axis right there. So now that I've drawn my 5 points, it's just a simple matter of connecting the dots. As long as you have those points right, doesn't matter what the shape looks like. That looks like a parabola, but trust me, that would work.
All right.
Okay? All right. What else you got?
This one was pretty complex. All right, yeah, we can do this one. Y equals 2/3 cosine of x over 2 minus pi over 4.
Is that it?
Yeah.
What's different about this from my standard format? Besides the fact that it's cosine instead of sine. Very significant thing. What's b?
B is 1/2.
Notice that my b here is outside the parentheses. My b up here is inside the parentheses.
Oh, right.
If the b is inside the parentheses, then this is not the phase shift. That is still C, but it's not the phase shift. C is only the phase shift if B is outside the parentheses. So the way we solve that is we factor out a half so that we rewrite this the following way. Minus what?
Pi over 2.
Pi over 8. Pi over 2. Sorry. No. You're exactly right. I'm taking pi over 4 and I'm dividing it by 1/2, which is the same as multiplying by 2 over 1. So pi over 2 is correct. Now I have it in my proper format, or not necessarily proper. I actually have dealt with some school districts that put the B inside as your standard. And then they define phase shift as C over B, as opposed to this format where B is outside the parentheses and phase shift is defined as C. Now that I have this in this format, let's go through. What's A?
A is 2/3.
What's B?
1/2.
What's the period?
Period is 4 pi.
What's C?
Positive pi over 2.
Which way is that a shift? So my phase shift is right pi over 2. And that's the way I would write it, is a big R. And D is 0. So this shouldn't be too tough. We're only going to go up to 2/3, down to 2/3. Where am I going to start and end?
You're gonna start at you're gonna start at pi over 2.
And I'm going to end where?
And you're gonna end at 4. No.
Add 4 pi to that number.
8 or 9 pi over 2.
9 pi over 2. So there's my beginning and end. What are these? This point right here. If this is 1 pi over 2 and that's 9 pi over 2, it's got to be 5 pi over 2. This is 3 pi over 2, and this is 7 pi over 2. Okay, so I'm starting right there. I'm ending right there. I'm going to go through that point, go through this point, I'm going to go through that point. Connect the dots, you're done.
All right.
Oh gosh, quite the artist I am. Okay.
Next one.
Another one. We'll leave that up there.
So y equals 2 minus sine of 2 pi x over 3.
Like that?
Yeah.
Okay, let's rewrite that in standard format.
So y equals negative sine of 2 pi x over 3 plus 2.
Now, notice that when my b is, when I don't have any phase shift, it doesn't matter if b is inside or outside the parentheses.
Yeah.
It's only if I have a phase shift that it's critical. There's no phase shift, so normally what I do, there's something pretty important here though. Let me think about that for a second. Yeah, I think it does matter. Whether we do the reflection or the shift first matters. Just like it mattered with polynomials. Remember in your pre-algebra, if you had a complicated translation or transformation and it had vertical shifts, horizontal shifts, and reflections in it, that it was critical that you do the reflections first.
Okay.
A is 1, negative 1 we'll say, because we need a reflection. B is 2 pi over 3, which makes the period what?
It's going to make it just 2.
It's 2 pi divided by 2 pi over 3.
That'll be 3.
And the vertical shift is up by 2. Notice if I go up by 2 first and then reflect, it looks like that. But if I reflect first and then go up by 2, it's going to end up above the x-axis. So it matters which you do first.
Mm-hmm.
So my reflection causes it to look like that.
All right.
Now let's move, in other words, this being 1. Yeah, let's put that 1 down a little lower so I got room. Let's make this 1 here, this minus 1 here, and this 3.
Mm-hmm.
So when there is a vertical shift, probably the best thing to do is to draw a dotted line through your new axis of symmetry.
Mm-hmm.
So I'm going to pretend that this dotted line is like the x-axis.
Okay.
Okay? So period, there's no phase shift, but we have a period of 3. So let me put 3 out here. It means I have to start right here. Since the sine curve normally starts at the origin,
Mm-hmm.
I'm going to go down first, not up. I've got to divide this into fourths.
It's going to be 3 halves. 4 halves.
In other words, the best way to do this is to take this number, divide it in half to get this point, and then take this number and divide it in half to get this point.
Yeah.
So that's 3/4. This is 6/4. This is 12/4. It's got to be 9/4. Halfway in between 6/4 and 12/4 is 9/4. All right, so now I guess we're ready. We're going to go down to 1, back up through the axis of symmetry, up to its high point, and back down to the axis of symmetry.
Mm-hmm.
There you go.
All right. Do we have time for one more complicated one?
Normally I wouldn't mind going over, but I have a 6 o'clock with a brand new student who I have to call a few minutes early to get them set up. I've got time for a simple one. Or go ahead and give me the complicated one. I'll try to go through it fast.
Okay. 2 plus 1/10 cosine 60 pi x.
Like that?
Yeah.
Let's start by putting the 2 on the other side. Now we have it in standard format. B is what?
B is 60 pi.
So the period is what?
1/30th. Yeah, 1/30th.
Remember, when this number is greater than 1, it's going to scrunch up your curve.
Mm-hmm.
So this is a lot greater than 1. This is like 180. So our period goes from a regular size number to a small fraction.
Mm-hmm.
All right, that's probably enough. There's no phase shift. We know we're going to go from, what's our vertical points that I'm going to go up to and down to?
1/10 and negative 1/10.
That would be if I didn't have this 2. With that
right.
2, I'm going to go
2 and 1/10.
2 and 1/10 to what?
Negative 2 and 1/10.
No, to 1 and 9/10.
Oh, yeah, that's right.
Okay? In other words, the difference between your maximum and your minimum divided by 2 is equal to A.
Mm-hmm.
Well, and my dotted line goes through that. In other words, I got to go 1/10 above my dotted line and 1/10 below my dotted line.
Yeah.
And I'm going to go with a period. I'll just label that like that.
Mm-hmm.
And that's going to be 1/60th. That's going to be 1 over 120. And that is going to be halfway between 1/60th and 2/60ths.
Mm-hmm.
Must be 3 1/20ths. No, yeah. Yeah, because this is 1 1/20th, 2 1/20ths, 3 1/20ths, 4 1/20ths.
Yeah.
Okay. And I'm going to start right here. Oops.
Mm-hmm.
Right there. Going to go through my line of symmetry right there. Going to go down to my bottom point right there. Come back up through my line of symmetry right there. And end it right there.
Okay. All right. Thank you.
All right. Talk to you next time.
All right. Bye.
Bye-bye.